up everyone? Welcome back to my YouTube channel. Again, I am Rica Casabuena from DLSUD ECE, and for today's digital electronics block, we'll be discussing about experiment number 4, the Boolean Algebra. So if you are new to my channel, don't forget to subscribe and hit the like button. Enjoy!
Let us first understand what is Boolean Algebra. Boolean Algebra is a special language of digital circuits, a mathematical method of expressing, analyzing, and designing logic circuits. It is a mathematical system used to deal with binary or two-value functions.
Now, to provide you an overview, our objectives is to check the theorems of Boolean algebra in practical approach. And of course, to simplify the logic equations using our Boolean algebras. So, as a reminder, before we start the experiment, the materials will be discussed on each part of our experiment procedures. So just keep on watching and don't forget to enjoy while doing and constructing your circuit.
Now that you're ready, let's start. For our part 1, the double inversion circuit, we will be needing a 7404 integrated circuit. As you connect the IC, don't forget the notch or the polarity of our IC. The pin number 2 of our IC is connected to our pin number 3. Now, let us put our input A, this will be our input A, sa ating pin number 1. So, white wire will be our input A, and our output will be on pin number 4 of our integrated circuit. So, this will be our output, the orange wire. And sa ating output, don't forget our resistor. Okay? Yan, i-connect natin yung ating resistor sa pin number 4. So, dito siya in series with our pin number 4. And for our indicator, let's not forget to have an LED in series with our resistor. With our 360 ohm resistor, don't forget our VCC here on the VCC pin of our integrated circuit, and don't forget to ground our components. Okay, connect it to our negative side, and then don't forget to ground our LED para umilaw siya. So yan, for figure and part 1, this will be our circuit. Now, for our output for part 1, if A input is on 0, so dito sa negative, as you can see, hindi umilaw yung LED. And if it is in 1 or connected to our VCC, as you can see, umilaw yung LED. So if the input is 0, the LED will not turn on, and if the input is 1 or connected to the VCC, the output will be 1. Now, for our part 2, absorption theorem, using the AND or combinational circuit, we will be needing a 7432 and a 7408 integrated circuit. As you can see on the circuit, the pin number 3 of the 7408 is connected to the pin number 1 of our 7432. The pin number 2 of both of the IC are connected. And from the second pin of our 7408, which is connected to the pin number 2 of our 7432, our input A is connected as well. Our input B will be connected to the pin number 1 of our 7408. So, ito yun. And our output is connected to the pin number 3 of 7432. So, maglagay tayo dito ng resistor and LED for our output. Again, same connection, series ulit sila. LED will be in series again, okay? And don't forget our grounding, okay? Let's ground all of the IC. So let's ground it. And let's ground our LED. Also, let's ground our second IC. And don't forget our VCC connection, which is nandito sa kabila. So for the second part, the absorption theorem, this will be our circuit. Now, for our output, if A and B inputs are both in 0, okay, as you can see, so hindi umilaw yung ating LED. If input A is 0 and input B is 1, lipat lang natin dito sa VCC connection. Again, LED is turned off. If we interchange the connection, input A is 1 and input B is 0, umilaw na yung ating LED. And if both of the inputs A and B is connected to the VCC, umilaw pa rin yung ating LED. So that's our output for part 2. Now, for our figure 4.4 or N combinational circuit, as you can see from the circuit, we will be needing the same integrated circuit, namely the 7432 and the 7408 integrated circuits. The pin number 3 of our 7432 is connected to the pin number 2 of our 7408. The pin number 1 of both of the IC is connected to each other, like this. And from the pin number 1 of our 7432, we will be connecting in series our input B. Meanwhile, our input A will be connected to the pin number 2 of the 7432. And now, for our output, it will be connected to the pin number 3 of the 7408 IC. Again, our output will be the same. It will be a resistor, a 360 ohm resistor in series with our LED. Don't forget the essence of our grounding, okay? Grounding of our LED, the grounding of our integrated circuits, okay? Both of the IC should be grounded, okay? And of course, don't forget our VCC connection, which is connected to our integrated circuit, the 7432. So for our figure 4.4, this will be our circuit. Now, for our outputs, let's turn on our voltage supply. If both of the inputs are connected to the ground or to 0, as you can see, the LED is turned off. If A is 0 and B is 1, as you can see, the LED is turned on. If A is 1, okay, if A is 1 and B is 0, as you can see, the LED is turned off. And if both of the inputs A and B is connected to 1, okay, so as you can see, umilaw yung ating LED. So that's the essence of our combinational circuit. Now, for our part 3, distributive law, we will be needing, again, the 7432 and the 7408 integrated circuit. As you can see, the third pin of the 7432 is connected to the first pin of our 7408. The sixth pin of the 7432 is connected to the second pin of the 7408. The first pin of the 7432 is connected to its fourth pin. So it's 1, 2, 3, 4. And from that connection, we will be connecting our input C to the fourth pin of our 7432 in series with its connection. So yellow will be for our input C. Input B will be connected to our second pin of the 7432, and input A will be connected to the fifth pin of our 7432. Again, before we run the circuit, we will be grounding all of its components. First, okay, the 7th pin of the 7432, let's ground it. And for our output, we will be connecting the resistor and the LED to our third pin. Repeat note, the third pin of our 7408. Again, don't forget our resistor, our 360 ohm resistor. It should not be greater than that because LED will not turn on. And of course, don't forget our LED in series with the resistor. And now, let's ground all of our components. Don't forget to ground the LED. Don't forget to ground the 7th pin of the 7408. It's really important so that our connection will be correct and appropriate. And of course, do not forget our VCC connection for both of the integrated circuit. It is important so that the voltage supply will be regulated all throughout the circuit. So for our part 3, the distributive law, this will be our circuit. Now, for our output, if all of the inputs are at 0 or connected to the ground, as you can see, the LED is turned off. Now, if only the input C will be connected to the VCC, the LED was turned on. Now, if only B is connected to 1, okay, if only B is connected to 1, then the LED has been turned on. The LED instead has been turned off. Now, if B and C is connected to the voltage supply, the output will be 1. Now, if only A is connected to our voltage supply and both B and C is connected to ground, the output is 0. Now, if both inputs A and C is connected to the voltage supply, the output will be 1. Now, if both A and B is connected to 1 and C is connected to 0, the output will also be 1. And lastly, if all of the inputs are connected to 1, okay, A is 1, B is 1, and C is 1, of course, our output will also be 1, meaning the LED is turned on. So that's our truth table for our distributive law. Now, for our last part, the second demo of our distributive law, we will be needing, again, a 7408 and a 7432 integrated circuit. The pin number 3 of the 7408 is connected to the pin number 2 of our 7432 integrated circuit. Input A is connected to the pin number 2 of our 7408, okay? White is for the input A. Input B, which is our orange wire, is connected to the pin number 1 of our 7408 integrated circuit. Input C, which is our yellow connecting wire, is connected to our 7432 it is connected to the pin number 1 of the 7432 integrated circuit. Okay, and of course, let's not forget. And now, for the last touch, let's not forget our output, which is connected to the third pin of our 7432. The same setup, we will be using a 360 ohm resistor in series with the third pin, okay, just like this. And again, don't forget our LED, okay. It is really important because it will be our indicator for the outputs. Again, as a reminder, let's not forget the essence of our grounding is really important for the appropriate connection of our circuits. Okay, let's ground our resistor and our LED, our integrated circuits, both of them. It's important that they are grounded. Okay, and the other one is here. And of course, don't forget our VCC connection for both of our integrated circuit here on the other end. Okay, so our circuit is set up. This will be our circuit for the last part. Now, it's time for our outputs. If both or if all of the inputs A, okay, A, B, and C are connected to input 0 or to the ground, the LED is turned on. Turned off. It's turned off. Meanwhile, if only the input C is connected to the voltage supply or 1, the output will be 1 as well. Now, if only the input B is connected to 1 and A and C is connected to 0, the output will be 0. Now, if both of the input B and input C is connected to the voltage supply and A is at 0 or the ground, the output will be 1. Now, if only A input is 1, okay, and both B and C is connected to the ground, our output will be 0. Now, if A and C is 1 and B is on the ground, then the output is 1. Now, if A is 1 and B is 1 and 0 and C is connected to the ground or 0, the output will be 1 as well. And lastly, if all of the inputs A, B, and C is connected to the voltage supply or all of them are 1, our output will be 1 as well. So that's our truth table for our distributive law demonstration number 2.
As a conclusion, the double inversion law states that the double complement of the complement of variable equals the variable itself. Meanwhile, in algebra, the absorption law or absorption theorem is an identity linking a pair of binary operations. Lastly, the distributive law states that the multiplication of two variables and adding the result with a variable will result in the same value as multiplication of addition of the variable with individual variables. With all of our experiments from experiment 1 to experiment 4, we can have an overall summary of all of the laws and Boolean theorems that we used all throughout our experiment papers. I hope this table on the video can help you out to better understand the Boolean operations and Boolean algebra theorems that can help you solve more Boolean problems and can help you out with your future studies. Now, for our recommendations, please don't forget the proper grounding of our circuit components. It is really important so that our LED will serve its purpose. And of course, the appropriate and correct electronic components should be used in the circuit for it to function. And it is really important to remember that the value of our resistor for the output should not be greater than 600 or 1000 ohm for the LED to turn on. And of course, the most important of all is our input voltages or our voltage supply, so that the circuit should have its voltage flowing through the wires. So that's our recommendations. Now, after all of our experiments, we were able to understand and to realize the Boolean algebra theorems and their applications. I hope you learned something from our vlog and digital electronics episode today, and I hope you'll not forget to subscribe and hit the like button if you like my video. So see you on my next experiments and on my next vlogs, and I hope you're gonna have a great day ahead. Again, I am Rika Casubana, your future electronics engineer, saying good day and God bless to you, future engineer. See you!